Okay, so let us begin our journey today. What are we going to be doing? So we are going to be reviewing, going over question 1 in paper 1. And what I call this, I call it the general algebra question. And the topics that are going to come up are definitely going to be equations, inequalities, and nature of the roots. So one of the things I saw in the chat here were people were asking about going over inequalities. So we can do that today. And I just want to, let's actually ask, what is an inequality? So an inequality, for me, initially has to do with this crocodile mouth thing. So if I say to you -3 is less than 4, then that inequality for me is a true statement, right? But if I said -3 is greater than 4, then that wouldn't be a true statement. Okay, so that's the sort of most simple use of it. Sometimes we might add something like kind of a line like that, which means less than or equal to. However, in this scenario, that can't be true because -3 is strictly less than 4. So normally what you see with inequalities is you see something like that. And so x is less than 4 is going to consist of all the numbers that are less than 4. And normally when we deal with inequalities, we represent them using a specific form. I'd love to know from the people in the class, how do we normally represent our answers with an inequality? What tips can you remember? Or what, maybe your math teacher did something. How do we normally represent inequalities? Pop your hand up, come say hello. I promise I don't bite, especially not over the internet. Or you can pop it in the chat. Who can remember whenever you have an answer which is an inequality, so say like x is less than 4, what do we normally illustrate that answer with? So this might trigger a few memories for you guys, but I was thinking a number line. X is an element of, yes, or a number line, yeah. So if we have a number line, let's say we did this, and the critical value is going to be 4. If I want to illustrate my answer, what we normally do is we say, to illustrate this answer, we have an open circle, and that shows us that we're not including 4, and it's all the values to the left of the 4. So this answer is shown what we call a number line or a sign table sometimes. Lesego, yes, Awami, you guys are on the right track. Okay, so often we'll have to solve an inequality. So let's say, let's back this up for a second. So let's say the question was, solve the inequality x minus 4 is less than 0. Then what we would do is we would add 4 to both sides, and we'd get x is less than 4. So that would be the inequality solved. And then we'd illustrate it using this number line. So in a lot of ways, inequalities are a lot like equations, and we'll see this in today's lesson. Now, what would happen if instead of it being a less than, it was a less than or equal to? There would be a slight adjustment I would need to make to my number line. Does anybody know what I would need to do? So I've changed the question now. Okay, so I've made this a less than or equal to, and what I'm asking is there any change to my drawing? Include the 4. Lesego, you are absolutely right. How do I include the 4 mathematically? Like, what do I need to do to this drawing to include the critical value of 4? Let me just get rid of this -3 part. all you need to do is shade the circle. Yes, Lesejo, you shaded. And so this is going to be x is less than or equal to 4. Love it. Okay. Now, what does happen in grade 11 is sometimes you have inequalities that look like this. So we might say you've got to solve for the value of x in this. Give me a thumbs up if you've seen a question like this. So the question would be, solve the inequality x squared minus 4 is less than or equal to 0. Give me a thumbs up if you've seen that before. Okay, I see a couple of thumbs up. Now, I want to ask you, what makes this question more difficult? It's still an inequality because I see the crocodile, I call it the crocodile mouth, I don't know, it looks a bit like. You still got this funny sign, it's not equals. What makes this question more grade 11 than grade 10? I'd love to know what you think in this question makes it a bit harder. Or what's different compared to the first one? Well, it is an equation, but it's sort of an inequality really because of the fact that there's the less than or equal to. But I was thinking, what about the exponent? Yeah, what about the power of 2? So we call this a quadratic inequality. And the reason it's called a quadratic is because of the power of 2. Okay, that's it. Now, what we normally do when we solve quadratic equations is we factorize them, and it's the same with a quadratic inequality. So as I look at this, how could I factorize this expression? Yeah, it's a different, oh, okay, Awami has recognized in the chat that it is a difference of 2 squares. And with a difference of 2 squares, you have 2 brackets. And it's the square root of the first bracket, and then minus plus, and then it is 2 like that. Now, there's different ways of doing a inequality. There's different ways of solving them. The value that I was going to show you now, there's one with a graph and there's one with critical values. So some people will draw a drawing like this where they say, okay, let me do my way first, and then I'll talk about the other way. If I ask you to look at this expression, what are the critical values or the values where this expression will be 0? What value of x will make the expression 0 and be what I call the critical values? So it's going to be 2 and minus 2. And on my number line, I'm going to write minus 2 and 2. Now, if we think of this as a parabola, and this is what some methods will do, this is a happy parabola. And so it would look like this with minus 2 and 2 as the roots. Now, another way of doing it is to ask yourself, okay, well, I want to know where this function is positive and where is it negative. So the first region that I want to look at is this region over here. Do we think this region is positive or negative? Put it in your chat. Put it in the chat if you think it's positive or negative. If x is greater than 2, is the expression as a whole positive or negative? So you can kind of see this on the inequality, or what you could do is you could put a number in. So if I took like the number 3, if I took the number 3, which is, 3 would be in here somewhere, and I put it here, 3 squared is 9. 9 minus 4 is 5. That's positive. So that's going to be positive. Now, as I go over a critical value, it's going to switch sign. So it's going to be negative here and then positive again here. And you can see this on the graph or the parabola that's representing the x squared minus 4. So this expression will be positive when x is greater than 2. It will be negative between minus 2 and 2, and then positive when it's less than minus 2. Now, the final bit. The question asked us, where is the expression negative? So in order to write down the answer, I need to describe the region between here and here, and I need to include the 2 endpoints. And in inequality notation, the way we would write that down, the region from minus 2 to 2 is just going to look like that. And so my answer to the question is x would be greater than or equal to minus 2 and less than or equal to 2. And so that would be the answer to that inequality. Now, I kind of went with this and wanted to show you kind of a progression. I do know that a lot of you will still feel a bit confused, and that's why we're going to do more questions today. But can I just get a quick thumbs up if you broadly followed what I did, and thumbs down if you feel very lost, as I want to get a feel for the room. I know that this topic is a little bit tricky, but there was a question from a student who wanted us to specifically address this topic. Okay. Use those fingers, guys and girls, definitely. Okay. All right. Then we'll go back to inequalities in the main question for today, but the other important idea for today that we need to be aware of is something called the quadratic formula. And the quadratic formula looks like this. And it helps us solve quadratic equations. And so just be aware that as we go forward today, you may need to use that. Okay, enough of me talking. It's time for more doing. So we are going to look at this. These are old exam questions. And I'm going to ask you to start today by solving question 1.1.1 and 1.1.2 for me. So solve for x, and I'm going to give you 2 minutes now, and you are going to do the best you can to solve these 2 questions. If you get stuck, you're going to raise your hand, but otherwise you are going to try and do this yourself. Okay. Off we go. Once you have your answer, just pop it in the chat. So there's a little bit of a code for you guys in the second question. It says correct to 2 decimal places. And that's actually sending you a message here. So I'm wondering if anybody knows what that secret message, correct to 2 decimal places, is telling you to do with the question. Maybe someone just pop your hand up and give us a little description. What does, when the answer says correct 2 decimal places, what are they secretly telling you? I'm sure somebody must know. La Seco, you are winning. It's telling you secretly that you need to use the quadratic formula. Yes, indeed. Who has the answer for question 1.1.1? It's a bit of a sneaky one, but it's only worth 2 marks. So you have to ask yourself, what is the answer here? And I'm going to suggest one of the answers is x is 0. What is the other answer? So the other answer is going to be whatever we get when we get 2x plus 1 is 0, because this is already factorized. This has been factorized, so we just break these 2 parts. The x equals 0 is the one part, and the 2x plus 1 equals 0 is the other part. And so if we take away 1 from both sides, we get that. And then if we divide both sides by 2, we should get x is negative a half. Okay. Now, that is the first question. I still want to see some answers in a moment or two for the second question. What normally catches students with this question is they multiply it out. And then when they multiply it out, they go, oh, what sort of question is this? And the sneaky thing is that it's already been factorized. It's almost like the teacher did some of the work for you. And that's why it's only 2 marks. So to help you with the second question, I'm going to put the quadratic formula on the board for you. The good news is this question is already in standard form. So we know that A is 5, B is 2, and C is minus 6. So let's see what answers we get for that. Can you work out the answers to this one? Okay, let's see what people are getting for this. So this is there has been a question like this in almost every grade 11 paper forever. So there's always going to be at least one where you need to use the quadratic formula. And the quadratic formula even works in normal cases. So a lot of students choose to use it most of the time because it's so reliable. But obviously it takes a bit longer than normal factorizing sometimes. Keep those answers coming. I think I'm seeing some good stuff there. So that bottom bit is going to be 10 for sure, because 2 times 5 is 10. And then we have 4. So it seems like we have a delta value of 124. So, and the delta value is this b squared minus 4ac. It's this thing over here, and that's going to come up later in the question. So let me just check my answers. I see Nolitando has agreed with it. Is indeed minus 1,31 and 0,91. So let me just write that in. We have x equals 1.3 minus 1.31, or x is equal to 0.91. Okay, thumbs up if you felt okay with that. Thumbs down if you felt unsure. Just want a quick bit of feedback from the class. So I'm going to ask you to take a screenshot if you need to of the working out, because we're going to do one more question before the break, and it's going to be an inequality question. But I need to remove this part first. Okay. All right. So let me get rid of this. Now, in the meantime, while I'm cleaning my board, I want you to have a look at trying to solve question 1.1.3. And all I'm going to say to you about question 1.1.3 is, if it was an equation, what would your first step be? So it's not an equation. It says solve for x in each of the following, but it is an inequality. But the first step should be the same as an equation. So I want to know, what would your first step be if you were solving it as an equation? And then let's go from there. So I'm solving for x, but I see that sort of crocodile mouth thing. I see Awami's made a comment. Who else has got a comment to make? What do you think I'm going to need to do? Normally, when we solve an equation, we like to have everything on one side. And so what I think is I would move the 3x to the other side, and then I get this inequality, which I have to solve. Teddy has said, bring the b over. I agree. Mikhail, I agree. Awesome. Okay, now, I want to know, what is the next step? I know, this, I can see that this is a bit like the one I was talking about earlier. It's got the power of 2. So its shape, if it was a parabola, if we wanted to visualize it, it's going to look like this because of the number. When the number in front of the x squared term is positive, we get a smiley face or a happy parabola. If it was negative, it would be pointing down. So we know what we're dealing with, but we want the values of x that make this whole expression greater than or equal to 0. And we need something in particular to help us. What do we need? So I think we need the critical values, or the roots of this equation. And how we get that is to factorize it. Okay? So I want you to try and factorize it now, and then I will factorize it with you and see if you can get what the answer is. And then just put done in the chat when you say you factorized this. I use a particular method, but you could use the quadratic formula. I don't mind. But I want to know when you've had a chance to factorize it. Just put done in the chat. So let's see if I can. I'm going to get a -4 here, and I'm going to get a +1 there. That gives me that. So the factorizing that I see when I read off my inequality or my trinomial, I get 2x plus 1, x minus 2. So my next step is I'm going to try and represent this answer on this number line here. Or basically, I want to know what my critical values are. So using the fact that I factorized this, what are the values that are going to make this expression 0? It's kind of like I'm really wanting to know what these two values are. How am I going to find them? I need a value of x that would make this thing 0. So that would be one answer. And then I need a value of x that will make this thing 0. Yeah. So you could kind of split it just like we do with quadratic equations, but you can kind of see that this is going to be 2, and this one is going to be minus a half. Now, if you look at the graph, or if you even put a value in, you can see that this is going to be positive, this is going to be negative, and this is going to be positive. So what is my final answer going to be? Well, I want where it's greater than or equal to 0. So I color this in. I want that region, and I want that region. And so my answer is going to be x is less than or equal to minus a half, or x is greater than or equal to 2. And that would be my answer. Now, I went a bit faster because I'm going to give you a chance after the break to do another one. But just, again, give me a thumbs up if you followed my working, or if you would like me to explain something about what I did here. Please raise your hand and I will gladly go over something. I know there are different methods, but if you're generally happy, give me a thumbs up in the chat. Okay. Are there any questions or comments before we move on? I hope that this has been helpful in learning how to solve quadratic inequalities. For the most part, if we have to review this, we treated it like an equation, we moved it all to one side, then we factorized, and normally in an equation, we would have a equals 0, right? So over here with an equation, we would just have an equals 0, and then we give the answers. The difference with an inequality is that we have this sign table type thing, where we know where the expression is positive and negative, and so we answer it in this form over here. All right, we've been working for a solid half an hour, so what I want now, I want everyone on their feet. I want you to turn your cameras on, and we are going to stretch it out. So, Lebo, if you could help me to encourage our fellow students. Oh, and we're stretching it out. I want to see your faces, guys and girls. Come on. Oh, listen to that clicking.
Come on, guys. Please join us in the stretch. Give your mind a break.
I want to see those happy faces. Show me like...
Put on your cameras. Let's see your faces.
Yeah, there I can see Lebo's face. Hi, Lebo.
Hi, Miss Liz. Come on, guys. You don't want to miss out. Don't get FOMO.
Come on. If you show me your face, I'll play you a song. How about that?
Ah. Sounds like a good deal.
It does, but I have to see some faces.
Is it load shedding or just feeling shy today?
All right. Let's see.
Ah, Londega flashed her face for like 2
Did
seconds.
she? Come on, guys. All right.
Yeah.
Totally. Everyone's a bit camera shy today. Hi, Lucico.
Hi, Lucico.
It is lovely to see your face. All right. Let us do a little bit of a brain break. So here is my question for you guys and girls. Divide 20 by a half and add 30. What do you get? Divide 20 by half and add 30. What do you get? Keenus, love it. Awami, aha. Rosaria, okay. So let's divide 20 by a half and add 30. Now, oh, Teddy is in on the, okay. This is sneaky because when you say divide by a half, it's not the same as saying halve it. It's so weird. 20 divided by a half is actually the same as, and what I do is I use this trick where I say 20 over 1. Let me scroll down a bit. 20 over 1, and I use this thing called top and time. So if you had 20 over 1 over a half, that's exactly the same as what's above. But all of you know that if you divide by a fraction, you can write it like that if you multiply. And so this bit over here in the block is equal to 40. So 20 divided by half is the same as saying double 20. And so the correct answer is, in fact, 70. So whenever you divide by a fraction, remember, when you divide by a fraction, you're going to end up with actually a bigger number, not a smaller number. But they definitely worded that in a way to kind of draw you in. And yeah. All right. So that is today's brain break. Give me a happy face if you liked it. Give me a unhappy face if you, I can't, I do get unhappy, but I don't know how to do it now in the chat. Okay.
Oh, great, Rosaria.
Okay. Yeah. All right. Back to the maths. Back to the maths. So I'm glad you enjoyed the brain break in Buso and Rosaria. So let us go to what's called a simultaneous equation. Now, this is going to be in every single paper that you write until the end of matric, and there is definitely some technique involved. And so I want you to try and do it by yourself first, but if you get stuck, please raise your hand. And those who are feeling generous, maybe you can put some top tips in the chat that you think might be helpful as we think about how to solve 1.2. So we're going to do this one now. Solve for x and y simultaneously. Yeah, nice, Mikhail, nice. We can do 1.1.4, Teddy, absolutely. I just wanted to do the thing one first, but I will do 1.1.4 as well, yeah. When you start a simultaneous equation, you have to make some decisions, and certain decisions can make your life a bit easier. So I am wondering in the class, what are the main decisions you make when you start your simultaneous equation journey? What are the things that your teacher has told you that could make life easier, or methods you use? I'm a little bit interested in that if you have a moment to put something in the chat. What do you think, Dimpo or Kinas? What techniques have you learned about this year for handling simultaneous equations? I always think that simultaneous equations normally have a harder one and an easier one. And so for me, the easier one here is the one that I initially focus on. I think the best choice you can make is to make y the subject of the formula. Does anybody know, excuse the pun, why I chose y and not x? So the reason I chose it is if I look at my second equation, Awami said you can't factorize it. Yes, that's part of it. The other thing is I looked at the second equation and I looked, it only has one y. So it's got 3xy. And in the second equation, there's only one y. So if I'm subbing something in, I want to sub in the least amount of times. So the first step is the easier equation is always better to start with and put into the harder one. But you could have made either x or y the subject of the formula. And I chose y because it made me do the least work putting into the second equation. And so this is a technique called substitution. And so the substitution step is basically to replace the y with the value you've got from the first equation over here. And so this is going to be 2 minus x. Let me make it a little bit thinner. Now, what I want to see in the chat at some point is the answers you guys are getting. So that's what we're waiting for next, or some questions about where we differ or clarifying. So at this point, we have a choice. We could use the quadratic formula, or we could use other methods to help us kind of get to what x is. Some people might divide through by -2, because they might say, look, this -2 kind of gets in the way. And so if I divide everything by -2, then I would get x squared. You don't have to do this. I think a lot of people would benefit from just going straight to the formula now. So a is -2, b is 6, c is 8. But you could also divide through by -2, and you'd get that quadratic equation, which is equivalent. So I want to see a few more of those answers in the chat. or I want some questions from the students. Mbuso, you and me are agreeing. We get x is -1 and 4, and there's a number of ways we could have done this. Mbuso, can you tell me how you got your y values after this? And you can just put your hand up to answer me. You don't have to type it. How did you get your y values now that we both got x values? And those students who used the formula, you should get the same answer as me. You should be getting 4 and -1.
Hello, sir.
Hey, how's it going?
Good, sir.
Very good. How did you get the y values?
So I just substituted the x value that I got into the equation y equals to 2 minus x.
Okay. So did you get -2?
Yes.
For when, okay. And for the second one, what did you get? For the -1 x value?
I got 1, sir.
Okay, so let's have a look. You put 2 minus -1. But now the sneaky bit is minus and minus is a plus. So you end up getting 3 actually. Does that make sense? Because you go -1. So I think I might have lost you there, but that was sounding great. So what I got is my y is -2 here, and my y is 3 here. And I loved what was done there. We basically took the x values, we put them back into the original simplest equation, and we just put them basically where there was an x here, and then we evaluated them for that situation. So when there was a 4, 2 minus 4 gave me the -2. When there was a -1, 2 minus -1 gave me 2 plus 1, which gave me 3. Mbuso, thank you so much. Again, thumbs up if you feel okay with this, and we can move on. Hands up if you have a question. Thumbs down if you feel a bit lost. Okay. Well, let's try and squeeze in. Well, let's have a look at question 1.1.4. We're not going to have time to do the whole thing, but I want to ask you 1.1.4, what type of question is this? It's a particular type of question. And so I want to just ask if you recognize it. What type of equation is it? It starts with an S. Well, yeah, it actually is an LCM equation too, but these things look to me like something called a surd. So this looks like a surd equation, but you're right, it's a surd equation that has fractions. And so the key to answering this question, maybe I won't finish it today, but is to multiply by this thing. So you're going to multiply both sides of this equation. Everything is going to be multiplied by the surd 2x plus 5. And when you do that, you're going to get 2x plus 5 times 2x plus 5 minus, now what's going to happen in the second part is that the multiplication is going to knock out what's below, and they're going to cancel out. So you get -3 equals -2 times. So all I've done is I've multiplied everything by that. Now, I'm actually not going to do the whole thing today because I think it will be confusing, but I do want to know, does anybody know what the square root of 2x plus 5 times the square root of 2x plus 5 is equal to? I'll give you a little hint. There's my hint. So what is the square root of 2x plus 5 times the square root of 2x plus 5? Yes. So the square roots essentially get knocked, when you have two of them next to each other, they undo the square rooting process. And this would end up being 2x plus 5 minus 3. And then this thing on this side would still be like this. Now, what I can do is I can clean my life up a little bit. But this is where we get to what's called a surd equation, because we have a surd over here, which needs to be dealt with. And what I'm going to start with in the next lesson is how do we actually deal with a surd equation properly? The first, this is a tough question, right? So it's 6 marks. Step 1 was to multiply by the LCM, okay, which was this thing. And that wasn't straightforward. Step 2 was to clean it up. Step 3 is going to be able to do the surd equation, which I will carry on with in the next lesson. But give me a thumbs up if you followed me so far. If you followed the basic thinking with the surd equation. Okay. So I just want to do a little preview of the next lesson before we finish off tonight. Now, one of your biggest friends will be realizing that exam papers have a structure, right? So question 1 in grade 11 always has the structure. If I want to show you another paper from another year, and I want to ask you, do you recognize some similarities from the question that you just did? Now, in the next lesson, we're going to do this question. But do you see how there are quite a few similarities? And just give me a thumbs up if you can see them, thumbs down if you can't. So for me, question 1 looks quite the same. Question 2 looks quite the same. That's the quadratic, you have to use the formula. This is what we call a surd equation. You can see the surd hanging out there, which we're going to talk about in the next lesson. This is an inequality question. This is a simultaneous question. And then this one down here, which we'll also talk about in the next lesson, is a nature of the roots question, or it's about the delta thing. And so the good news is, if you keep doing the same question again, you start to see these similarities. And so the learning just becomes easier and easier. And so I just wanted to kind of show you this, the structure basically today. Okay, I think we're going to call it, we're going to finish the lesson now, but are there any questions or comments? Lebo, could you put the poll out for the students so they can give us some feedback?